Hello and welcome to a special edition of Cracking the Cryptic, where today we're going to look at a properly difficult Killer Sudoku. For those of you who've been looking at the deadly Killer Sudoku reviews we've been doing over the weeks, you may after a while think you know everything there is to know about Killer Sudokus. Well, not quite. All of the puzzles that I think we've done to date have been machine generated. Now there is also available on specialist websites hand-produced Killer Sudokus of exceptional quality and difficulty. The one we've got on the screen at the moment was featured on Grandmaster Puzzles, Thomas Snyder's website, where the great and the good contribute some of the best puzzles in the world today, and you can find it on www.gmpuzzles.com. And this Killer Sudoku was voted the best puzzle in the sort of Killer Sudoku genre, if you like, in 2017. So it is an exceptionally good puzzle. It was compiled by Serkan Yürekli, who those of you who are familiar with the name may know is one of the world's finest puzzle setters. Now, you should see the puzzle up on the screen at the moment. Let's just spend a moment or two to talk about it. The cells marked 0 at the moment, they are cells where no information is known about these cells. So don't take it that they have to sum to 0. That's not the case at all. They're simply cells that are not within a cage that contains a number. So that's already a difference between this Killer Sudoku and the normal Killer Sudokus we see in the Times or the Telegraph. That makes it substantially more difficult because you've got much less information to use. Now, what I'd recommend is that you pause the video now and spend just a couple of minutes thinking about how you might even start to put in numbers in this puzzle. Because it's quite instructive to do that, to try and even come up with 1 or 2 numbers in the grid. Give it perhaps 7 minutes, which, believe it or not, is listed as being the sort of time you should be aiming for if you want to be a world Sudoku champion. So if you want to be Grandmaster ranked on grandmasterpuzzles.com, you need to be doing this puzzle start to finish in 7 minutes. Now, I'm telling you, that is a very stiff yardstick. So anyone who achieves that, fantastic. But without further ado, I'm now going to attempt to do the puzzle and to explain logically how to do it. So first thing to note, let's just get that out of the way. We can see, I guess, this 7 down here, that has to be 1, 2, 4. So we may think we're off to a good start. And you can see here we've got a 6 box with which has to be 1, 2, 3. Let's put that in, and we can see with the 1, 2, 4 checking this cell here, we can actually put a number in this. Oops, not that number. We can put a 3 in here, and we're off to a start. I'm not going to say a good start because I'm not sure that 3 is going to tell us very much at all. Okay. So where do we go from here? Well, I think what we have to do is to take a look at this enormous 41 cross in the middle of the grid and think about what this means. This 41 cross is 7 cells in size. Now, therefore, we can say that the 2 numbers missing, if you like, from this 7-celled cage have to sum up to 4. Why do I say that? Well, imagine this cage was instead 9 cells large. Then we would know it would contain all of the numbers 1 to 9, and it would sum to 45. Well, this cage is only 7 cells large. So somehow those 2 numbers that are missing need to sum up to the difference between 41 and 45. So they're going to sum to 4, i.e. this cage does not contain a 1 or a 3. Now, does that help? Well, it does help a bit, because if we look at column 5, we can see if there's no 1 or a 3 in these 5 cells in the middle here, there needs to be a 1 or a 3 or both, perhaps in this cell. Well, clearly this can't contain a 1 because it sums to 11 in 2 cells, so it needs to contain a 3. And if it contains a 3, it must contain an 8. So actually we can write that in like that. That means that this 8 has to contain a 1, so we can add the 1 and the 7 like that. Now, what else can we say? Well, now we've got a 7 and an 8 franking all of these positions, but we know this 41 box, although it doesn't contain a 1 and a 3, it contains every other number, so it must contain a 7 or an 8. Well, the only places a 7 and an 8 can go now are into these two positions. And here we see the first, well, I mean, we've already seen an example of how brilliant this puzzle is in terms of its design, but when you have these hand-generated puzzles, they have a very structured, logical solution path. And you can see this 7 and 8 here is immediately useful because it helps us to resolve this 15 box here. This 15 box now must be 6 and 9. We can see further now that we've now got a 6, a 7 and an 8 in row 5. And look, this 9 box therefore can only be 4, 5. Because it can't be 6, 3, it can't be 7, 2, and it can't be 8, 1. And in turn, we've got the 4 already in this column here. So in fact, this cell here has got to be a 5. That gives us a 4 in the other position. And in fact, look, we've got a 22 box here. Now a 22 box in 3 cells, we know that contains a 9. And therefore, this cell here has to be a 6. And therefore, this is a 9. And as this cell is a 6, that means this 22 box is in fact made up of 5, 8, and 9. Like this. Now, one of the things about this software is that we can see if we look at this central row here, we still need to place a 1 and a 3 in this central row. So these must be here and here in some order, because we know that the 1 and the 3 aren't contained within the 41 cross in the middle. So that's got to be a 2. And the software doesn't allow me to put in an option of a 1 or a 3 here unless I actually make this cage into a number. So that's what I'm going to do now. You can see I've labelled these two cells 99. That's not to indicate they have to add to 99, that's just to indicate that if you like, I've resolved the fact that they have a limited number of options. So that just helps me to record the logical thought path. Now, let's have a look. I think the next thing we need to look at probably is column 1. We can see we need to place a 1, 2, 3, 4 and a 7 in this column. But this 21 box here is quite limited now because it clearly can't contain a 1, 2, 3 or a 1, 2 or a 3 in this position, because that would mean that these two cells would have to sum to at least 18, which is impossible. And indeed, if this was a 4, these two would have to sum to 17, which again would be 8 and 9, which is also impossible. So in fact, this has to be a 7, which means these two cells have to sum to 14 without using 9. So this is a 6 and an 8 in some order. And just that. Unbelievably, that is useful because we now know that there is an 8 in one of these two positions. Pause the video if you can't see why that's the case. I'll explain it, but try and prove it to yourself. Because what we've got here is if this is an 8, this will be an 8. Or in the other way around, this will be an 8 and this will be an 8. Either way, there's no way any of these 4 cells here can contain an 8. So the 8 is forced into these two positions here. Now, if that's the case, this 13 cannot contain an 8. And what's more, it can't contain a 9 because of this 4 here. So in fact, this 13 is 6, 7 in some order. And that actually resolves the fact this now must be an 8 and this must be a 6. Therefore this is an 8 and this is a 3. Okay. I just wonder whether we can use the same sort of trick. We've also got a similar thing going on if you look up here with the 1s. We've got if there's a 1 here, there'll be a 1 here, and if there's a 1 here, there'll be a 1 here. So there's definitely no 1 in any of these positions. And look, with this 7 therefore, this 7 cannot be a 1, 6. And it can't be a 2, 5 because we already have a 5 in the box. So this 7 in fact is 3, 4 in some order. Okay. And we know that there's a 1 in one of these two positions here. Okay. What I'm wondering about now is whether we can use the fact that in this 3x3 box and this 3x3 box we've got a lot of numbers already given. So we can see up here, for example, we need to place 1, 2, 6 and 7 in the remaining boxes here. So I think we can label this one a 99 box. Label this one 99 box. This one 99 box. And do the same thing down here and put in the alternatives that we've identified as possible. So let's go back here. So this box now is 1, 2 or 7. This is 1, 2, 6 or 7. This is 1, 2, 7, 2, 6 or 7. And the thing I am noticing here is if we look along row 2 of the grid, we've actually got a quadruple here on the numbers 1, 2, 6 and 7, i.e. we've got 4 cells that can contain exactly these numbers. So we know that those numbers will appear in some order in these 4 cells, and the other numbers in this row therefore need to be, we've already got a 3 there, so the other numbers in this row are going to be 4, 5, 8 and 9 in some order. So this cell, for example, has got to be 4, 5, 8 or 9. This cell 4, 5, 8, 9, and this cell too. So let's resolve that one. 4, 5, 8 or 9. Doesn't look like it's taking us any further, so let's try and do the same trick down here on this box where we've got to place 3, 5, 8 and 9. See, this is going to be 3, 5, 9. I think probably what we need to do here is to use an unusual property of this 33 cross here. And a 33 cage in a Killer Sudoku, well, it has to contain a 9, because otherwise you can't get to the 33. But actually, interestingly enough, it also has to contain an 8. And we can see that because if we sum 9, 7, 6, 5 and 4, which would be the highest numbers we could use if we didn't allow ourselves to use an 8, we only get to about 31, I think. So we know there's an 8 in this cage, and you can see that there can't be an 8 in any of these positions or here because of this 8. So in fact, we can write in an 8 in this cell here. I'm not certain how useful that's going to be yet, but we can hope. And then we could use the fact, if we remember when we looked at these 1s here, we said that there couldn't be a 1 in one of these two positions because it's either going to be a 1 here and a 1 here, or a 1 here and a 1 here, but there definitely won't be a 1 in either of these positions. So let's just remove a 1 from these two cells, and in fact that gives us a hidden triple in row 2. We've now got a 1 and a 2, a 1 and a 7, and a 2 and a 7 in 3 cells. So this cell here has to contain a 6. Let's write that in and see if it helps. And then we need to again, try and use this 33 books again, I think, and the fact that we have a 3 in row 9. So we can see if we take the 3 across and use simple Sudoku logic, we either need to put a 3 into this big 33 cage, or the 3 will go here. So the simple question is, can we put a 3 into this box? Now, if we put a 3 into this box, we can immediately say that the other 4 cells would need to be 6, 7, 8, and 9 in order to get to the 30 we'd require to make the cage work. But that's impossible, because if this, say, let's make this a 3. If this was a 3, we could put a 9 here. But this box here would have to be a 6 or a 7, which is impossible. We already have a 6 and a 7 in this 3x3 box. So there is no 3 in any of these positions. Therefore, in fact, the 3 is over here. And we can set this cage to be correct. Means we can remove a 3 from these 2 positions here. And this is really quite beautiful, because now let's look at this 3x3 box again. Now we can see we need to still place a 1 and a 2 in this box, and for exactly the same reason we couldn't have a 3 in this box, we definitely can't have a 1 or a 2. If we have a 1 or a 2 on this box, the remaining 4 numbers in it would need to sum to either 32 or 31, which is impossible in 4 cells. So in fact, the 1 and the 2 must be in these 2 cells here exactly. So let's write that in. You can see if we scan across, that means that this cell here must contain a 4. And now we know that these 3 cells here are some combination of 4, 5, 9. Oops. So if we sum those numbers together, we've got 18 here, plus 8 is 26. So this number here must be a 7. And that is very helpful. That allows us to place a 7 here and an 8 here. And now these 2 cells have to be 5 and 9 in some order. And then we can see we still need to place, what would it be, 1, 2, 4 and 6 into these remaining cells in this 3x3 box here. So this could be a 1, 2, 4, this could be 1, 2, 4. This can't take a 1, remember, because of the logic we did earlier. So this is 2, 4, 6. 1, 2, 4, 6, like that. And you can see if you scan across row 8 now, we have another triple here. 1, 2, 1, 2, 4, 1, 2, 4. So this can't be a 4, this is a 5 or a 9. And the other thing we can see is because this cell here is 1 or a 2, the 4 must lie in one of these 2 cells in row 8, which means this can't be a 4 and this can't be a 4. So let's get rid of those 2 alternatives. Triple there on 1, 2 and 6 in these 3 cells. And of course the 2 is here already, so this in fact has to be a 6. Let's put that in. 6 there. And what do we have left to place in the central column? I think 4, 5, 9 still have to place. Might as well write that in now. We could do a little bit of Sudoku logic here as well, using the 1 and the 2 in columns 8 and 9. So we know that there's a 1 and a 2 in these 3 positions here. Let's just think about the 2. Can this be a 2? Now if this cell was a 2, you can see that that forces this cell to be a 1 and this cell to be a 4 within this 35 cage. So in other words, 3 of the 6 cells in this 35 cage would add to 7. And clearly that's impossible because the remaining cells would have to sum to 28, and that's not doable. So in fact, this cell here has to be a 2. Like that. Means there's a 2 in one of these two positions, but I don't think we can tell at this stage which one. And the next step is, yet again, just a real thing of beauty. Believe it or not, we need to look at this 33 box here and ask ourselves the question, what's missing from this box? So we have a 33 cage, which is 1, 2, 3, 4, 5, 6 cells in size. So just as we did all this work on the 41 box in the beginning, we know that the 3 missing numbers from this 33 box will sum to 12 in order to sort of bring the total up to 45. But the fascinating thing here is that you can see from this 8, and this 8, there is no 8 in this 33 box. So we know that one of the missing numbers, one of the numbers that needs to add up to 12, is an 8. Therefore the other numbers must be a 1 and a 3 again. So there is no 1 or 3 in this 33 box. And why does that help? Well, look, this cell here, the 127, cannot contain a 1. We need to remove the 1 as a possibility here, and therefore there is a 1 here. Extraordinary. Therefore this cell here can contain a 3, and this cell over here contains a 1. This cell is a 2, and this is a 1. And we need to place a 1 in one of these cells here. Well, we know there's no 1 here for the same reason we've just been discussing. So there is a 1 in this position. Just make that box work a bit better. And then look, we can do Sudoku logic again. We need to place a 1 in either this cell or this cell, and for the same reason again, this can't be the 1. So this is the 1 here. And look, this really breaks the puzzle open. We now have a 2 in this position, a 4 in this position, and a 1 over here. Sudoku logic forcing this to be a 3, this to be a 4. That means that this is a 4 here. I think that means this has to be a 5 because it's the only possibility left for this position. We can do a bit of tidying up now. We've got a variety of numbers in the grid that are no longer possible. 9, 9. Just go and take a 4. Let's fill in the options here. So we've still got to place 2, 4 and 7 into these positions here. You can see this therefore has to be the 7. That means this is a 2 and this is a 7. This is 2 and 4. Actually, this is resolved as well here. This has to be a 4 and this has to be a 2. You can see this 7 has to be a 1, this has to be a 7. This is a 1 and this is a 2. Which forces this to be a 2 because this position is checked by this other 2 here, so that's a 2 up there. And I think the rest of it's just going to be tidying up because I think we've actually done all the hard logic now, but I think you'd agree it certainly was not a straightforward puzzle and was probably the most interesting Killer Sudoku we've ever looked at on the site. We know from this 33 box here we're allowing ourselves a 4, a 6 and a 9 here in order to complete the box because we said it doesn't contain a 1, 3 or an 8. So 4, 6 and 9 down here. That means this cell down here resolves to be a 9 and this is going to be a 5. And this 4 here is resolving several of the items in the middle. This is going to be a 4, this is going to be a 6. Which means we can place a 3 here, and this is going to be an 8. Therefore this has to be a 3. And again now we can see that we need to, there's a 4 in one of these two positions. We have a 4 here, so this is going to be a 4. And this will have to be a 5 in order to complete this box. That means this is an 8. So this is now forced to be a 3. And this is going to be a 5. You can see this 35 box is now forced because we have a 2 and a 4 here and a 5. So the only other possibility is the rest of the numbers need to be 7, 8 and 9 in some order. We already have an 8 here, so this in fact is going to be an 8. These two numbers are going to be 7 and 9. And then we can use Sudoku logic here. This has to be a 3. This has to take a 6. And then we can see we need to put 5, 8 and 9 in the top row. Well, therefore this has to be a 9. 6 is the only number that's a possibility here. Therefore this number here has to be a 7. That in. And then the final bit of logic to finish the puzzle off. If we look at this 20 cage here, we know these 3 cells must sum to 15 because we already have a 3 and a 2 in the box. And the only available numbers here are 4, 5, 6 and 8. So in other words, these 3 cells here have got to be 4, 5 and 6 in order to add to the 15 we need. That's the only way of doing that. Therefore this has to be a 5. 5. And this is going to be 4 and 6, so this will be a 4 and this will be a 6. You can see that that's going to break the whole of the bottom part of the puzzle open like that. We're left with this being, what's it going to be, an 8, which means this is a 5, this is a 4, this is a 9, this is an 8, this is a 9. I think that's going to work. And I hope you agree that this is, this sort of puzzle, I wish we could do these puzzles every day. I mean, this is really a work of art. So thanks very much to the setter. Go and have a visit of gmpuzzles.com if you like the look of what you've seen today. And we'll see you again next time on Cracking the Cryptic.